Hello brothers and sisters, this is Mishako H, and in the last video we mentioned that we will be looking at procedural programming versus object-oriented programming. First of all, we'll begin by looking at procedural programming because we're not really concerned about it, and then we will move to object-oriented programming where we will look at the features of object-oriented programming because Java is an object-oriented programming language. Okay, so in case you hear me mentioning the word OOP, that means object-oriented programming. So procedural programming is a style of programming in which operations are executed one after another in sequence. For example, when you're given a lab assignment, you're required to perform the experiment following the procedures and steps given in order to get the results of the experiment. In such an experiment, each step leads to the next. In procedural programming, a programmer begins by assigning names called variables to reserve memory locations. The variables are then manipulated procedurally until output is obtained. For example, if you're finding the product of two numbers, you would first begin by reserving the memory for both numbers and then write the code to multiply the number, then either save the results to one of the numbers variable or to a new variable altogether. Object-oriented programming is similar to procedural programming but adopts a slightly different approach. This type of programming uses classes and objects. In object-oriented programming, you envision that objects belong to a class and resemble real-world objects, then you manipulate them to interrelate so as to have the desired output. Object-oriented programming has four principles. Number one is abstraction, number two is encapsulation, number three is inheritance, and number four is polymorphism. We will begin by discussing abstraction. Take into assumption that you're riding a motorcycle to school every day. You think of it as a means of transport and you understand the use of the gear on the left foot, the brake on the right foot, the use of the clutch and the front brake. You also know how to use the horn, the signal lights, the ignition system. You rely on this knowledge to ride, and unless you are curious, there is no day you think about how fuel flow to the combustion chamber and the complex mechanism that is needed in the engine and the gearbox for you to move. You wrap up all the complexity to simply holding the clutch, changing the gear and accelerating or decelerating. With abstraction, you manage ideas rather than events. The complexity of the motorcycle above is managed with a few ideas like turning the gas throttle to accelerate instead of thinking about how fuel pump works in correspondence to the throttle or changing the gear without worrying about the mechanism of the gearbox. In object-oriented programming, a powerful way to manage abstraction is through the use of hierarchical classifications. This allows you to layer the semantics of complex systems, breaking them into more manageable pieces. We will look at the use of abstract keyword in the coming video. Our next principle is encapsulation. Encapsulation is the mechanism that binds together the code and the data it manipulates and keeps both safe from outside interference or misuse. One way to think about encapsulation is as a protective wrapper that prevents the code and data from being accessed by other code defined outside the wrapper. Access to the code and data inside the wrapper is tightly controlled through a well-defined interface. Data hiding in encapsulation ensures that the variables of a class will be hidden from other classes and can be accessed only through the methods of their current class. We will explore encapsulation further, where we will look at private, protected, and public declarations of variables and the use of getters and setters. Inheritance is the process by which one object acquires the properties of another object. This is important because it supports the concept of hierarchical classifications. With inheritance, an object needs to define those qualities that make it unique within its class. It can inherit its general attributes from its parent. Let us assume that you're, for example, building a racing car game in Java. You have different types of sports cars that you envision to add or that you want to add in the game. And the sport cars fall under a class of small vehicles, which also falls under a large class called vehicles. With inheritance, you can obtain all characteristics of vehicles, like having engines, wheels, gearbox, and many more features from the main class vehicles, and then inherit class size from class of small vehicles, and all that is left is you to just define the features that make the sports car unique, or those features that are specific or limited to the particular sports car that you're describing. The next principle we are going to look at is polymorphism. Polymorphism comes from a Greek word that means many forms. Polymorphism is a feature that allows one interface to be used for a general class of actions. The specific action is determined by the exact nature of the situation. Let's look at a specific example of a program. In this program, we have a public interface that we call sports car, and then we have a public class that we call vehicle, and we declare the class, another class like public class Ferrari, extends vehicle and implements our interface, which is the sports car. So from this example, we can safely say that Ferrari is a vehicle, Ferrari is a sports car, and Ferrari is an object. In the next video, we will install and configure Java Development Kit, JDK, and if time is enough, we will test it with our first program. Otherwise, thank you for watching my video tutorial. Don't forget to like, comment, subscribe, and turn on the notifications. I hope to see you in the next video.